Good morning. I have great news for you. We're at the end of Year 1 statistics. So combined with the stuff you did with Mr. Godber earlier in the year and the stuff you've done with me, that's it. And so what we're going to do today is look at the online textbook at page 80 and 81. And I'm going to encourage you to work through those questions, particularly the ones that have got E's, which mean they are typical exam questions. In a minute, I'm going to have a go at question 1 and question 10. So you may choose to pause the video at this point, have a go at those two yourself, and then watch my solution. Other than that, of course, you've got the solution bank to look at the answers yourself. After that, we're going to do 2 more weeks. That's 4 lessons of mechanics, finishing off mechanics. And that leaves us with 3 weeks to do some pure maths, looking at an area of maths called proof, which again was something we did at GCSE, but which we do in much more detail at A-level. And that will bring us, combined with the stuff you're doing with Mr. Godber, to the end of Year 1 work. So if you manage to keep up with the videos, we will start next year having had no disadvantage with the closure. And that puts us in a really advantageous position. So pause the video now, have a go at 1 and 10, and then come back in a minute and I will show you what I've done. What I meant to say as well was that I'm going to put my money where my mouth is, and I'm going to do question 1 without a tree diagram. See how you get on. Okay, so with question 1, the key thing in this question is that these beads are being taken out and then replaced. So the colour of each bead every time you take it out is independent of the previous one because the numbers aren't changing, and that means my denominators are always going to be 15. So what's the probability? And I want to know the probability that the first and second beads are red and the third bead is blue or green. Now I could do red, red, blue and red, red, green as 2 separate outcomes and then add them together, but I'm going to do it slightly quicker than that. So I have got 7 red beads, so the probability I pick a red bead is 7 out of 15. I put it back in, so the probability the second bead is red is still 7 out of 15, and the third bead is blue or green. Well, 3 blue, 5 green, so that's 8, so that's 8 out of 15, and I suppose I should have done this beforehand, but yeah, 7 out of 15 times 7 out of 15, frantically typing away on my calculator, times 8 out of 15 gives me a rather horrible looking fraction. Perfectly okay to leave that as fractions. If you're ever looking at a mark scheme and it gives you a decimal but then says OE, that means or equivalent. So a fraction or decimal, and as a decimal it looks even more horrible, so I'm going to leave it like that. So that's A. B, 1 red, 1 blue and 1 green bead are chosen. Doesn't specify that it has to be in that order. So I've got the possibility of red, blue, green, red, green, blue, blue, red, green, blue, green, red, green, blue, green, red, blue, green, blue, red. 6 possible outcomes. And at this point you might be thinking, oh dear, that's looking like it's going to take a long time. But what's the probability that you get a red bead first? 7 out of 15. Blue bead second, well, don't forget all the beads put back, so it's going to be 3 out of 15, 3 blue, and green bead 5 out of 15. And do you notice where I'm going with this? This probability here is going to be exactly the same, isn't it? Albeit in a different order. This will be 7 over 15 times 5 over 15 times 3 over 15. And this will be the same, but in a different order. This will be the same in a different order. This will be the same in a different order. This will be the same, but in a different order. So my answer is 6 lots of that sum. And I'm going to cheat this time. I'm going to pause the video and work it out. Okay, 14 over 75. So my first probability, that's my first answer, and there's my second answer. I could have worked out all of these separately and added them together, but in general, if a question, particularly a 3-mark question, involves that much work, you've probably missed something which allows you to speed it up. So well done if you spotted that. No tree diagram in sight. I mean, you can see why I didn't choose to do a tree diagram. We're picking 3 beads, and at each time we pick a bead, we've got 3 choices. So you'd have one of those tree diagrams with 27 branches. So there we go, question 1. Next one, question 10. Okay, I'm hoping that this one is pretty straightforward because it's very similar to the one we did at the beginning of yesterday's video. So I can work out that x is 0.15 because that's what I need for all the probabilities to add up to 1. So the probability that of A, which is like in cake, is 0.45. That's the 0.3 and the 0.15 added together. And the probability of B is 0.55. And the probability of A and B, A intersection B, is 0.15. So if they are independent, the probability of A multiplied by the probability of B will give us the probability of A and B. This is how we test for independence. So here we go. Does 0.45 times 0.55, and I can already sense the feeling of disappointment, doesn't, does it? So that means they are not independent. So can I encourage you to work through the rest of that exercise, and in particular the E questions? As I said, it continues over the page. One thing we have found is that those students who are going to go on and get B's, A's and A stars, the very top grades, they are the students who commit to work through as much practice as they can. And so certainly completing the mixed exercise from every chapter in the stats book is an excellent way of reviewing the stuff we've done this year. So I encourage you to do that and get in touch if any of them cause you any problems. We will start mechanics again next week. Take care.